Welcome, everybody. So my name is Mike Clement. We'll be talking about taming scary production code that nobody wants to touch. I'm founding software craftsman at a company called Greater Sum. We're based out of Atlanta, Georgia, and we help teams to improve their development practices, including implementing some of the techniques that I'll talk about today. One thing that I am very passionate about is a principle, or it's a law from the open space technology, the open space community. If you're familiar with that, it's called the law of 2 feet, or the law of personal mobility. Part of that is that each of you is responsible for your own learning. And so if at whatever point during my presentation today you feel like you're not getting value out of my presentation, I invite you to go find somewhere else where you can find somewhere that you're getting value. There are 7 other great presentations simultaneously with me, and so I don't want you to be bored. I mean, I guess you could just recline a little bit more and just take a nap. It is after lunch, after all. One of the kind of unique things about this setup is the fact that it's being simulcast to like 4 other theaters. And so if people are max exiting those theaters right now, I have no idea. So anyway, I'm going to go ahead and get started. So when I first started to come up with this presentation, I originally called it this. Oh, there it goes. Modernizing legacy code. The problem with this title is that, 1, what does modernizing mean? 2, really, what is legacy code? So I know that people are probably in other theaters, but those of you that are in this theater, just throw out definitions that you have or you've heard of legacy code. COBOL, okay, so it could be older technology. Anybody else? Okay, so anything that's written by somebody who is no longer at the company. Come on, there's got to be somebody else. I know it's after lunch. It's a little bit sleepy. Pre-existing code. Okay, code that's not frequently refactored. A sunset project. Right, so there's a lot of different ideas out there around what legacy code might be, right? Older technology, code that's maybe out there that somebody else wrote. So a colloquial definition is legacy code is code that we've gotten from somebody else, right? The thing is that legacy code is often code that we've gotten from past self, right? How many of you have had the experience where you've gone in, you've seen some code, you're like, oh, what knucklehead wrote this? You go and you do a git blame, and it was you from 6 months ago, right? Got a lot of hands raised in here, right? From Wikipedia, we get this, a slang term for difficult to change code that we don't understand, right? That kind of goes back to the code that's not being refactored often. It could be because it's in a different technology. Now, the definition that I like, I mean, these are all good definitions, but an additional definition is from Michael Feathers in his book, Working Effectively with Legacy Code. And he says, legacy code is simply code without tests. So, why does he say that? Well, we'll get into that in a little bit. I had the opportunity about 6 months ago to talk with Michael Feathers, and I asked him, hey, if you were to update your definition of legacy code, would you say something different? And he kind of said, well, it kind of depends on what I'm trying to get across to somebody when I'm defining it. And he said in that particular case, right then, he was thinking, legacy code is when the people turn over faster than the code. So it kind of goes to the definition that one of these people came up with about, the person's not there. So if the people are turning over faster than the code, which is pretty much all the time, right? You have legacy code. So we'll go back to his definition of legacy code is simply code without tests, right? And he makes the additional jump that code without tests is bad code. I don't see people going, yeah, that's exactly right. I think there's a lot more shame potentially in the room right now. So that brings questions like code without tests, is that bad code? Now, bad is a little bit of a judgment. My different way of thinking about it would be that code without tests is scary code, right? Code without tests makes it harder for me to be able to safely make changes in that code because I have less confidence that the changes I'm making are not breaking other things. So, how I'm going to define it for today is legacy code is code without tests, but legacy code is scary code, scary production code, right? It's code that's been deployed that nobody wants to touch, right? You got to think about it like as if it were something like this. This does not look like fun to be able to deal with, right? Now, probably for some definition of working, these switches are working, right? But it's all about how much risk are we willing to take, right? We have opportunities here where, a lot of times we're looking at code and we're trying to make changes in code and it feels like this, that we're walking on a tightrope. And probably not even with the little safety harness that she has wrapped around her leg. So the things that we're looking at when we're trying to mitigate risk is, right, first, what changes do we have to make? If we do not need to change this code in order to enhance the value that this code is going to be giving us, there isn't maybe a compelling reason to go and make changes in the code. If there's the whole idiom, if it ain't broke, don't fix it, right? But we need to know what changes we have to make. 2, how will we know when we've done them correctly? And then 3, how will we know that we haven't broken anything? That third one is usually the trickiest bit. Usually when we're making changes in code we're not familiar with, we will run different tests manually or otherwise to make sure that the thing that we've implemented works. But without tests in place that other people have written or people that know what it is that it's supposed to do have written, it's very difficult to assess whether or not we've broken anything. At a previous job, we were working on a payroll system. So it was a comprehensive suite of software for small governments, and one of the things was payroll. We ended up breaking the payroll system, which is not a good thing to do, but it was only for specific scenarios, so it wasn't everybody. But basically what happened is that in the file that gets sent to the bank to do automated transfers, you have to put in all the entries, and then you have to have a total at the bottom. Well, something changed in the algorithm such that the rounding was off, and therefore the total was off by a penny, and therefore was failing to run people's payroll. I believe in that case it was only one customer, but again, it's one of those things where if we had had better tests in place, we would have been able to catch that. So the other thing is oftentimes the decision is made, let's not even make changes to this because even though we could do something to add value or to improve things, maybe the risks outweigh whatever it is that we're trying to get out of value. So here is a little thought experiment for y'all. So is it more important for software system to work but be hard to change or impossible to change or very difficult to change, or is it more important for the software to be easy to change but not currently working? Which would you prefer? What? So you could change it to work, but it doesn't currently work, right? So either a software system that currently works, that does what the spec says, fulfills the current customer requirements, but is very difficult to change, or a system that is not currently working, but is easy to change. Who would take number 1? Who would take number 2? Who doesn't like to raise their hand? Okay. So again, that second system, right? We would all prefer a system that we could make changes in, because if we have a system that we can make changes in, then we can get it to work. And not only can we get it to work for whatever currently are the requirements, we can then have the ability to expand it and improve it over time. So this is what Robert C. Martin says in his book, Clean Architecture. And right, this whole idea that if I have something that I can change easily, then I can make it work. So the trick here is, how do we keep our software soft, right? The reason why we call it software versus hardware is that it's easier to change. But if we have software that's hard to change, is it still software? And I'll let you think about that for a little bit. So this brings us to the legacy or scary code dilemma. So first, when we change code, we want to have tests in place, right? That's going to reduce our risk if we have tests in place. But how about if we have to change the code in order to get the tests in place? What do we do with this, right? It's kind of the chicken and the egg problem. I need tests to make changes, but in order to write tests, I need to make changes. So what we can use is we're going to have to make some sort of change, right, in order to get the tests in place. But what we can do is use low-risk changes using the core refactorings. So refactoring is a term that gets thrown around a lot in our industry at this point. But if we go back to the person who originally defined the term, Martin Fowler, he said it is a change to the internal structure of software without changing its observable behavior. So a refactoring is changing the structure without changing the behavior. Changing the structure without changing the behavior. Now, in his book, Refactoring, which the second edition just came out a couple months ago, he defines, in the first edition, he finds like 34 different refactorings, I think even maybe more than that. But another man named Arlo Belshi went through those and said, well, okay, there's all these refactorings. Let's see if we can condense them into core, what he calls the core refactorings. And he uses the CRUD acronym, which is often used for data access, create, read, update, and delete, to kind of classify some of these core refactorings. So basically, what we're doing is CRUDing names. We are adding additional information into the code that is allowing us to encode whatever it is we've understood into the application. So when we're creating variables, methods, parameters, and fields. We're updating the names, and potentially we're inlining, meaning that we're deleting those variables, methods, parameters, and fields. So I'm going to do a quick demo of some of those refactorings. Okay, excellent. Okay, so for example here, we have this r.days, and it shows up multiple times here. So what I'm going to do is I'm just going to take this. I'm going to use my tools. In this case, I'm using a tool in Visual Studio, an extension called Resharper. And I'm going to introduce a variable. Some of these are actually, you can use a version of these that are built into Visual Studio as well. Or again, if you're using any of the JetBrains IDEs from IntelliJ to RubyMine, they will do most of these core refactorings for you. So I can just say days. And now, everywhere that I had r.days, I now have days instead, right? And if I could also say, hey, there's this comment here that says determine amount for movie. So I'm just going to take everything from here down to here, and I'm going to do an extract method, right? So this is creating a method. So I'm going to take this code, I'm going to create a method. I'm going to call it determine amount. And now everything that was in this block of code, if I navigate to it, I can now see that this has that code in there. And I've given it a name, I've encapsulated it, and I've done it in a way that is low risk. Now what I can also do is I can do, again, the opposite, right? I had to my create. I can also inline the method. And inline, again, is the delete operation. It's the opposite of the create. So what I'm going to do is inline that, which will then take, oops, that didn't quite do what I wanted. I can take all of the, let's try that again. Oh, it's because days is used out here. Okay, here, I'm gonna undo. Okay, I'm gonna do this inline first. So I'm gonna inline this variable back. Okay, so then everywhere that days was, now we have r.days again. We're gonna pull this out and extract the method. And out. Okay, and then, like I was doing before, we can also inline that back into place. And then we have all of that code back here inline. Now, if you notice here, because of how the tooling does it, it replaced this amount with this amount 1. But one of the other things we can do is I'm going to rename this to this amount 2, and rename this to this, why not introduce, sorry. Rename this amount, and then I'm going to inline this amount too. And we're back to where we started. Again, one of the core things around the core refactorings is that they allow you to do things and undo things really quickly and easily. Again, for everything we can create, we can also inline it. If we don't like the name, we can rename it. So very simple, very automated things. And if you notice, one of the things that makes these particular changes low risk is, like, what did I use there? Did I do anything manually? No, right? So for all of those things, I used my tools, right? Software developers, we are in an age where we have a lot of tools available to us, right? We have IDEs that are very rich, very robust, can give us a lot of these core refactorings very easily. So if you're not using a tool that has refactorings built into it, I would recommend getting one. I do not work for JetBrains. I do not get any commission on whatever things you buy from JetBrains, but the JetBrains tools have been very good to me. There are a lot of open tools. If you use Eclipse for Java, there are some refactorings in Eclipse, either via the base thing or via plugins. So whatever it is you're doing, find automated refactorings. Because, and the other thing is with those is understand how they work. Right? Do things outside of your production code so that you can understand the behavior of them, right? So for instance, like it's a little bit confusing when I inline that method, it did that thing where it added an additional variable, right? I need to make sure that I understand what it is my tools are doing so that I can have confidence in them, right? Again, we're trying to use the tools to lower the risk, which means that we need to have confidence in our tools. So, as I kind of mentioned before, right? That whole idea of preserving existing behavior, this is, you know, we talk about like off by one errors, we talk about naming, but like preserving existing behavior as we're making changes in our code is really one of the biggest challenges we have as software developers, as people who are writing production systems. Oftentimes, who's ever felt like this when going into a part of their code? Right? Nobody? Maybe more like this? Right? And often the way that we try to approach these things is we do this. Right? Like, oh, well, I'm pretty sure I didn't break anything. I mean, it doesn't look like I broke anything. Well, we'll just deploy it to production and see what happens. Who's done that one? Okay, right? Is that the most effective? How many times has that worked out well for you? Sometimes it does, sometimes it doesn't, right? Again, part of it is sometimes how familiar we are with the code, but usually, I don't know as if I would want a 50-50 shot on whether or not I'm breaking production. Sometimes that ends up with us looking like this. Another approach is that we work with care, right? Okay, we're gonna make that change, and we're gonna like do little tests around it and kind of make sure that it works. But again, the problem is we're still working without a net. So what we're trying to get to is the idea of cover and modify. So again, the idea we're working with a net, we're working with safety harnesses, because again, what we're trying to do is we're trying to preserve existing behavior. So in order to preserve existing behavior, right, so adding new functionality, that's always kind of the fun, new, shiny part that like you make sure that works. But again, preserving existing behavior is one of the largest challenges. So what we can use is a technique called characterization tests. Now, characterization is describing the thing. It is not describing what we want the thing to be. It is not describing what the thing should be. It is not describing what somebody else wants it to be. It is describing what it currently is. So this is a technique that allows us to protect existing behavior. Now, this also means what might be encapsulated in existing behavior? Bugs, right? Everything that it currently does is what we want it to continue to do, right? There may be a bug in our code, there may be some problems in our code, but again, what we're trying to do with characterization tests is we're trying to preserve and protect all of the existing behavior. We're trying to describe the actual behavior of the system. I can't emphasize this enough, right? The idea here is that we are trying to put our code in a vice. We are trying to make sure that as we make other changes to it, that it doesn't move, right? That includes bugs. Now, at a second phase, after we've got the characterization tests in place, then we can go and fix bugs. But we want those bug fixes to be, number one, we want them to be intentional, and number two, we want them not to cause other problems in our code when we fix them. So again, it's like we're trying to lash down the code, we're trying to keep it in place. So again, I'm going to say this again, we're not checking for correctness, we're not checking to make sure it does what it should, we are checking for existing behavior. So the advantage of this particular approach is that we don't actually have to fully understand what the code is doing, right? Oftentimes when we go into legacy code, we're like, well, I need to spend some time and I need to understand how it works and this and that. Well, maybe you don't have to understand it quite as much as you think in order to start adding value and in order to start making changes to improve the code. So what I'm going to do is show off a tool for this. So what technologies do you all work in? Any .NET, Java, JavaScript? Okay, those that haven't raised their hand, what do y'all do? Salesforce, I'm sorry.
Python, C, Bash, Go.
Okay, Python, C, Bash, and Go. So I know for C and I know for Go, I know for Java and .NET, this particular tool is available for each of those environments. So what we're going to do, okay, so first off, how many times you've got into a project, you're like, oh, sweet, okay, there's a test project. And then you go click on it, and you're like, oh. That's so disappointing, right? That's all the tests. So we're going to do, okay, so I'm going to, I mean, it's not, they didn't even like set up a test fixture. They're just like, yeah, I'm going to create that because my boss said I needed to have tests. Okay. Now again, I don't really know what this, well, I do know because I know the code, but let's pretend I don't even know what the code is. So I'm going to have here a test. I'm just going to call it test 1 to start because I don't really know what it's going to do. And normally, when we write unit tests, there is what's called an assertion library built into whatever testing framework we're doing. So in the case of NUnit, you actually have 2 different assertion libraries. You have kind of the old assert equals, and then you kind of have the new assert that with the constraints, if you've done any NUnit. Pretty much all unit testing frameworks have an assertion library built in. Think Mocha uses Chai, which are 2 different things, but they kind of end up being together. What we're going to do here is we're going to not use the built-in assertion library. So we have the testing framework, we're still using NUnit as a testing framework, but we're going to change it and use a product, or it's not a product, it's a library. It's freely available, open source on GitHub, called approval tests. And in order to do this, I'm going to so it has a concept of reporters. It's not super important that you understand that right now. And I'm going to use a diff reporter. Okay, so what this allows me to do is I'm going to do pull that in, verify. And what this allows me to do is say, hey, I am going to call my code. Again, we haven't even looked at the code yet. But I know that the main method of the program, it creates a new rental info and calls statement, and then writes it out. So that seems like the thing that I want to test. So I'm going to run this. So in every other test that you've written, what do you need to have in order to have a useful test? Okay, maybe some setup. What else? You need an expectation. Do I have an expectation in here? No. So what we're going to do is we're just going to run the test. Now, because we have not specified any sort of expectation, it is going to fail. But because we have the reporter diff reporter, what it's going to do is going to pull up my diff program. And it's going to say, hey, this thing on the right, or this thing on the left, this is what you wanted me to verify. This thing on the right, this is what I currently have to verify against. And these are not the same thing. So what I can do is I can just say, because again, we're trying to capture existing behavior, we're not trying to make sure it's correct, I'm going to just do is I'm going to say everything on the left, everything that we got, I'm just going to copy it, and it's just going to be everything on the right. And I'm just going to save that. And now, if I run my tests again, it failed. Interesting. Why does it look like it failed? And the data is different, right? In one case, I had these two. Here, I can use this. I have these two different movies, and then this other one, I have two different types of movies, right? So, well, let's see. What if I run it again? Well, it failed again. But eventually, and I know this because I know the code, like occasionally, right, we have these problems where we have code that's dependent on data that's potentially changing out from underneath us. That being said, what we do have is we can look behind the scenes a little bit. So right now, what we have is we have this approved.txt. And so this is what we copied over to the right. So this is what we're currently saying is we've referred to as our golden master. And this is what we are comparing against, right? We also have what got received from the code, and this would usually delete if this passed. But this is there in place so that we can take a look at it. So what you're going to want to do is, let's try running those tests one more time and see if we can get it to pass. Okay, so it passed, right? So if our test is passing, what we want to do, notice the received doesn't show up. The approved.txt here, right? That guy, what we're going to want to do is we're going to want to put that into source control so that when we run these tests in some sort of deployment pipeline, in a CI server or whatever you want to call it, you then have that expected behavior. Okay, well, like we said, we ran into some problems there, right? So the problems are that oftentimes we have data, we have code that is accessing external resources and therefore is not going to be deterministic. And that doesn't really help us when we're doing tests, right? If we have code that is not deterministic, we can't, obviously, it's very difficult to test. So what we want to do is we want to introduce seams. And seams allow us to insert different data or sense different data that's coming out of our system, and therefore without actually editing the code. So the very natural place that there are seams is at a method boundary. So the technique we're going to use here is that oftentimes the thing that is happening in our code that is causing a problem is at the beginning of a method, the beginning of the method that we're calling. So we're going to use a technique called peeling to take that out. So again, if we go and look at this statement method, we notice that this first thing that comes up is get current customer. Now, if we go into get current customer, we can see why we were having problems. Half the time, it is getting one customer, and half the time, it's getting another customer. Now, your particular code probably shouldn't have some sort of randomizer for your data in it. But this is just sort of demonstrating the fact that occasionally we're hitting a database that is changing and things like that. So what we can do here is if we go back up to our statement method, which is the one we're trying to test, is we can peel off this get current customer. And so we can do that by taking the rest of the code that is in this method and using, again, one of our core refactorings, because, again, we're not completely confident in this test because we've had it fail before. What we can do is we can do a statement again. But in this case, the statement is going to take customer. I'm going to show this, right? The method statement is going to take customer as a parameter. So now we have a statement that goes and gets the current customer. Again, we're not trying to change the existing behavior, but we also have another method called statement where we do pass in a customer. So what we're going to do is update our test to go against our second, our new method here. We're going to make it public. And for ease, right now I'm just going to go and grab this customer that we were using here and inject that. Okay. So what we did, right, again, is we took statement, we took this part that was difficult to test or is random or is using some external resource. We're saying, okay, we're going to push that off. We're not going to have that under test. And then we're going to take the value that comes back from that and put that into another method, pass that into another method, and therefore now we can control what that customer looks like. So if we run this again, we can see that it passes, and I have a greater confidence that what it is that's happening is that this test is going to pass for the right reasons every time I run it, or at least pretty consistently, right? Again, without having to look at the rest of the code yet. Okay. Oh, one thing I didn't mention at the beginning, I may take questions at the end if you would like. If you do have questions, put them in Slack, unless they're like super hot and relevant, but put them in Slack. And if they're like, I don't understand anything that's going on, then raise your hand. But like, if you can put them in Slack, I will take some time after the session is over and answer them. So, okay, so we did peel. So the second thing we want to do is we need to inject our dependency. So in this case, we have some piece of code in the middle that is causing some sort of problem. And what we want to do is slice that out and then inject it. So I'm guessing most of you are familiar with dependency injection. You're using some sort of framework that does dependency injection for you. Unfortunately, sometimes you're working in legacy code that the developers did not know about dependency injection. Perhaps they were you 3 years ago or 6 months ago or however long ago, and that's fine. But again, what we want to do here is we have in here in the middle, we have this method, lookup movie. And again, for demonstration purposes, this just goes to a dictionary and looks up the movie. But you could imagine, again, that this is an actual database. It's actually going and hitting a database and looking up a movie. Now, if, for example, we were going to enhance this functionality at some point with additional movie types, right? Here we can see that there's regular movies, there are children's movies, and there's new movies. But you could see maybe we could have a horror movie section, a classic movie section, whatever it is. We could have different movie types, and we want to add those, but we don't necessarily want to keep updating a database with that. We want to have all of that stuff be able to be controlled within the code. So what we're going to do, excuse me. Okay, so we have this lookup movie method. Now, if you're in a language where functions are first-class citizens, you could just take this and you could inject that method. We're going to do something a little more object-oriented here, where we're going to take this method, lookup movie, and I am going to, first, I'm going to make it static. Right, so now it's going to take an ID, it has this movies, and it returns the movie. And then what I'm going to do is I am going to move to another type. I'm going to create a new type called movies. And that's fine. So now it does movies.lookupMovie. Now again, that still doesn't help us because again, it's a static type. So what we're going to do is go to lookupMovie. We're going to remove static. We are, I believe I can do this. No. Okay, usually I do this. So I can take off the static, which again will break this. But I can just say new movies, lookup movie. Okay, so I'm instantiating, I moved. Okay, recap. I took that lookup movie method, I made it static. I then moved it to its own class called movies, and now instantiate that lookup movies class. So what I can do here is I can say, okay, I am going to introduce this as a field. And this field is going to be initialized in the constructor. Okay, so now I have movies as a field, and it is created here in the constructor. This still doesn't help me. So what I'm going to do is I am going to introduce this as a parameter. And that is fine. Okay. I'm going to make that public. That's fine. All right, so movies is public. If I go to my program, notice it now injects some movies. And if I go to all my tests, it now injects some movies as well. Now, you're going to say, well, I can run this test again, make sure it's still working. But again, that's not quite going to be enough, right? That particular problem, like this still does not give me the ability to change the movies because I'm still using the movies that are already there. But what I can do is, oops, not that. I can, what do I want to do? Not extract superclass. I want to create, I can do it in here. Go to movies. I can, no, not this one, sorry. I want to create a derived type. Now this is going to be movies for test. What I can do is take this, I'm going to move this to my test namespace. And what I can do now is take the contents of that guy, right? Because I really wanted to do basically the same thing. movies in here already. Not sure what's wrong. That's fine. Oh, that's because I just have a class. I'm sorry, I am dumb. Okay. So I need to override. Sorry. I'm going to override. Oh, what? I do. That is true. Sorry. So I need to make this virtual. And now I can override lookup movie. There we go. OK. So this allows me then to make changes to this particular dictionary or whatever it is that we're using to store the movies, and I'm not affecting what is currently happening in production. And I'm not having to go to a database. You know, I can fake this lookup movie however I want. If it is actually hitting a database in production, I could put a dictionary in place and just do a simple lookup for the data that I need, and I don't have to like do the real database access. But we still are, again, this allows us to inject this behavior, inject this dependency on this movies database into our class rental info without making major modifications to our code. And now we can control that. Again, it's all about making sure that we have different things that we can control. So, okay. The other thing that we want to do here is we have this other customer that came up. What I'm going to do is, so there was a speaker earlier today, Izzy, that said code coverage is the worst metric ever. And I tweeted that that is probably true except for all the others. So I tend to think of code coverage as necessary but not sufficient, right? If your test is not hitting your code, then it definitely is not verifying that it's doing anything useful. But if it is, then it might be, and at least it's executing it. Now, if we look here, we can see that in our core here, our rental info, again, looking here with our tools, we can see here on the left that that is green, and that means that it is being covered. But then there's also places where it's gray, where it's not being covered. Now, we have intentionally, again, not covered this particular method. But if we look here in our statement method, which we are trying to cover, we can see here that there is a huge chunk here that is not being covered. And all of that code, we can look over here in the code, is around new and children's movies, right? So we're only testing regular movies. So what we need to do is, in our tests, add a second test. So again, before we can use code coverage, again, we're assuming code coverage is really a metric that is helping us determine the quality of our test suite. Is not helping us determine the quality of our code. And so what it's helping us to do is understand if our code is being executed. Now, if our code isn't, again, like I said, if our code isn't even being executed, then we have no confidence that it's actually doing anything useful. But we can, so we do want to make sure our code is covered. But again, it is a metric that can be easily gamed. OK, so I'm going to run these tests. I'm going to have a second test now. That second test is going to fail, which we know, because it hasn't run before. Again, we're going to take this value, which we, again, don't know if it is correct. We do not know if it's correct. Perhaps they should be earning 3 frequent winner points, and we do not know. But we are just, what we're doing is a characterization test. We don't care. Whatever it's currently doing, we want to continue to do. So now run it again, and we are passing, hopefully. OK. OK. So again, we've used 2 different techniques here. We used peel, where we just decided we're not going to test this piece of the code. We took out that create customer or get customer. Or if we have something in the middle, then we can inject the dependency. We can make sure that we slice out that piece of the code and inject it, or that functionality. OK, so at the beginning, we defined legacy code as scary production code that nobody wants to touch. You guys seem fairly comfortable with that definition at the beginning. What I hope is that as a result of what we've gone over is that we can take out the nobody, and now you have some of the tools that you need. That legacy code is scary production code that you want to touch, right? So again, at that same conference where I talked to Michael Feathers, and he's actually hiding here behind the, hiding here behind the podium. I don't know why it's not showing up, but Michael Feathers is hiding here behind the podium. Anyway, this is Jessica Kerr, and she said, when I hear legacy system, I hear useful, and I want to work on a system that's useful, right? Legacy systems, legacy code is around for a reason, right? It continues to run because somebody is using it. Somebody's getting value out of it. If they weren't getting value out of it, it was never getting executed, they just shut down the system. And so, working with legacy code may be difficult, it may be hairy, but there are techniques we can use to reduce the risk. Now, again, the thing is that when we're working with legacy code, one of the things we want to do is we want to not just go in like a Marine, drop in, fix something, and then get out, right? That is a very common way to try to deal with legacy code. Is to just like, well, it's a mess. It's like a war zone. I'm not going to engage with it. I'm just going to get in. I'm going to get out, right? It's almost the edit and pray mentality. The thing is that if we use these techniques like characterization tests and core refactorings, what we can do is when we encounter a change that is difficult, we can refactor to make the change easy, and then make the easy change. So if we look at the code that we've been working on, right, if we had to add code for a new type of movie or change how frequent render points are calculated, or all of those different things. Again, we didn't really understand the code, but if we wanted to make any of those changes, what we would want to do is get some tests in place, refactor the code so that it's easier to extend, and then make the extension, as opposed to just going in and doing what we can, because we're just contributing to the mess at that point. We're just making the code more and more difficult for the next person. So hopefully, I've armed you with some techniques that are useful and will help you out. Here are some resources that I've mentioned throughout the talk. First is Michael Feathers working effectively with legacy code. And if you are interested in that peel and slice idea, you can look, and Llewellyn Falco has some videos on YouTube, and then more detail on the core refactorings. If you are interested in the code that I used, you can go to my GitHub. If you're interested in this presentation deck, if you go to blog.softwareontheside.com, you can get the slides. And if you'd like to interact with me, you can contact me via email or Twitter, or again, I'll be checking the Slack afterwards. Thank you for your time, and if you do have questions, you can come down and talk to me afterwards, but have a great rest of your conference.